Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this video lecture. We continue with our unit 4 and our next compound is diazomethane. Next compound is diazomethane. And formally we write it as CH2N2, CH2N2, diazomethane. First of all, we see preparation of diazomethane. First of all, diazomethane was prepared by a scientist, Von Pitchman. Von Pitchman in 1890. First of all, diazomethane was prepared by von Pitchman, but nowadays this method is only of historical importance. Nowadays, this method given by von Pitchman is only historical important. So, other important method we have one method known as Moore and Reed's method. Moore and Reed's method. This is very important for preparation of diazomethane. Moore and Reeds, the scientists, which are developed this method in 1961. In 1961, we have second method also, and third one is also. So first of all, we see second method, Becker's method. Becker's method. And third one is Mackey's method. These three methods developed by different scientists. First, von Pitchman in 1980. Nowadays, this method is not in use, only of historical importance. So, other method developed by different scientists. One method is developed by Moore and Reeds in 1961. Second, Becker's method, and third, Mackey's method. So, let us see one by one all of these methods. First of all, Moore and Reed's method for preparation of diazomethane. Diazomethane. Moore and Reed's method. Moore and Reeds in 1961 prepared diazomethane in quantity and quantitative yield by alkaline hydrolysis of bis N-methyl N-nitroso terephthalamide. I write down this structure. Moore and Reed's method. Moore and Reed's method. Moore and Reeds take a compound, namely bis N-methyl. This is bis N-methyl N-nitroso terephthalamide. In 1961, Moore and Reed prepared diazomethane in quantitatively yield by alkaline hydrolysis of bis N-methyl N-nitroso-terephthalamide. Alkaline hydrolysis with the help of NaOH, 70% solution of NaOH. So CH2N2 and sodium salt of terephthalic acid for balancing 2 mole of NaOH is required and 2 diazomethane produce. Diazomethane produce. So this is first method. We prepare diazomethane. Now we see second method. Second method developed by Baker. So it is known as Baker's method. Baker's method. N-methyl N-nitroso-paratoluene sulfonamide. Paratoluene sulfonamide on distillation with ethanolic potassium hydroxide gives diazomethane. Bakers developed a method. In this method, he used N-methyl N-nitroso-paratoluene sulfonamide. Paratoluene sulfonamide. We see reaction N-methyl N-nitroso-paratoluene sulfonamide. I write down the reaction. N-methyl N-nitroso paratoluene sulfonamide. N-methyl N-nitroso paratoluene sulfonamide on distillation with ethanolic potassium hydroxide. Distillation with ethanolic potassium hydroxide KOH in ethanol. Ethanolic potassium hydroxide gives diazomethane. Diazomethane. In this method, N-methyl N-nitroso-paratoluene sulfonamide is not directly available. So, for N-methyl N-nitroso-paratoluene sulfonamide prepared by different method. Paratoluene sulfonyl chloride, which is treated with methylamine or aminomethane, and further it is hydrolyzed, gives N-methyl paratoluene sulfonamide, and this product N-methyl paratoluene sulfonamide treated with nitrous acid HNO2 gives N-methyl N-nitroso-paratoluene sulfonamide, and after this N-methyl N-nitroso-paratoluene sulfonamide is distillation with ethanolic potassium hydroxide gives diazomethane. This is second method. And now we see last Mackey's method. Number 3 or last method is Mackey's method. Mackey's method. In this method, methylamine hydrochloride, methylamine CH3NH2HCl, methylamine hydrochloride, and nitroguanidine. I write down nitroguanidine NH2C NH NO2 and NH. Nitroguanidine. This is nitroguanidine. Guanidine. GUADI. Guanine. GUANIDINE. Guanidine are allowed to react in KOH solution with the help of potassium hydroxide solution. The product is treated with nitrous acid, which on this treatment we get a product. First of all, methylamine hydrochloride and nitroguanidine are allowed to react with potassium hydroxide solution. We get a product CH3NH CNH NO2 NH minus HNO NH3 and minus HCl. This product is now treated with nitrous acid. This is treated with nitrous acid HNO2, or we also write down by this compound as HONO, nitrous acid. This product is treated with nitrous acid. We get N-methyl N-nitroso N-nitroguanidine. I write down the structure CH3 N NO C NH NH NO2, and this C contains NH. This is N-methyl N-nitroso. This is capital M. N-methyl N-nitroso N-nitroguanidine. GUANIDINE, nitroguanidine. And this compound warming with potassium hydroxide. N-methyl N-nitroso N-nitroguanidine is warming with potassium hydroxide gives diazomethane CH2N2, diazomethane. So in this Becker's method, first of all, methylamine hydrochloride, nitroguanidine are allowed to react with KOH solution, and this product is treated with nitrous acid HNO2. We get N-methyl N-nitroso N-nitroguanidine, and the latter compound, this compound N-methyl N-nitroso N-nitroguanidine gives diazomethane on warming with KOH. So these are three methods for preparation of diazomethane. Now we see the uses of diazomethane. The most important use of diazomethane is as methylating agent for the hydroxyl group. Diazomethane is used as methylating agent. And hydroxyl groups, especially acidic, namely carboxyl or phenolic, especially for carboxyl and phenolic. Methylating agent for hydroxyl group, especially acidic group carboxyl and phenolic. The second important use of diazomethane is in synthesis for some compounds known as acid synthesis. Second important method is acid synthesis. So we see the detail of diazomethane application in this lecture. First of all, we methylation of acid. Methylation of acid. Methylation of acid. Diazomethane is mainly used for esterification of carboxyl groups. The reagent also affects the methylation of phenol and some mineral acids. Phenol and some mineral acids. We see carboxylic group. So RCOOH carboxylic group treated with diazomethane. So methylating group RCOOCH3 CH3 introduced. So this is in acid methylation for acid. Also we see for phenolic compound. As for example, we see phenol C6H5OH. This is phenol and treated with diazomethane CH2N2. Then C6H5OCH3 CH3 introduced, substituted by one hydrogen, and this is phenol, and this compound is known as anisole. Anisole. So phenolic group also converted into alkyl group. In practice, an ethereal solution of the reagent is slowly added to solution of the compound to be methylated in a suitable solvent at 0 degrees Celsius until a faint permanent yellow color is observed. Since the conditions of methylation are very mild, the reagent is of great importance for methylation of such compounds, which are sensitive to strong acids. Sensitive to strong acids. So these are methylation of acid and phenol. We saw here phenolic compound. Now we see methylation of alcohol. Methylation of alcohol. Alcoholic compound. Alcohol can also be methylated by diazomethane in presence of ethylated boron trifluoride or fluoroboric acid as catalyst. As for example, we see the alcoholic compound ROH is treated with diazomethane in presence of BF3 boron trifluoride. It converted into methylated group. So for alcohol, diazomethane in presence of ethyl boron trifluoride as catalyst gives methylated compound. On the basis of this property, diazomethane is used as methylating agent for carbohydrates in determining their ring structures, determining their ring structures. So we see more application or property of diazomethane as carbonating or carbohydrate determination. Number 3, methylation of carbonyl compound. Carbonyl compound. Diazomethane also react with aldehyde and ketones to form a mixture of ketone and ethylene oxide. Ketone and ethylene oxide. So we see example, one aldehyde compound RCHO is treated with diazomethane, then carbonyl group affected and gives ketones and ethylene oxide. So RCHO is converted into RCOCH3. This is ketonic group, and RCHCH2O. This is ethylene oxide. In this reaction, we get major component as ketone and ethylene oxide as minor component. For ketonic group, we see or treatment with diazomethane ketone, well-known component CH3COCH3 acetone is treated with diazomethane in presence of H2O as a catalyst. H2O is work as catalyst, so we get one component as ketone CH3COCH2CH3 major component, and minor component as CH3 twice CCH2O. This is major component ketone, and ethylene oxide is minor. So methylation of carbonyl compound aldehyde and ketone gives mixture of ketone and ethylene oxide. These are the application or uses of diazomethane. Next example or application we see for diazomethane is number 4 is ants Einstein reaction. Einstein reaction. Diazomethane is also used in the Einstein synthesis, which consists in converting an acid into its next higher homologous compound. Acid into its next higher homologous compound. As for example, we have a carboxylic group RCOOH it is treated with sulfonyl chloride gives RCOCl, and this compound is treated with diazomethane CH2NH2. So it converted into RCOCHN2. It is known as diazoketone. 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 And also we get N2 plus CH3Cl methyl chloride. Diazoketone as a intermediate step. Now this diazoketone RCOCHN2 is treated with H2O in presence of silver oxide Ag2O as a catalyst. As a catalyst, we get next homologous acid. Next homologous acid. This compound contains only one carbon and this have a two carbon. So in Ernst-Sturt's reaction or synthesis, a acid convert into its next higher homologous compound. In this synthesis, it must be noted that in the absence of catalyst, here we use Ag2O as catalyst, and in the presence of water and formic acid, if water and formic acid are treated, then diazoketone produce hydroxyl methyl ketone instead of acid. This acid is not produced, but in presence of formic acid, HCOOH, formic acid, if absence of this Ag2O as catalyst, instead of Ag2O, we react diazoketone, water and formic acid, then it is converted into hydroxymethyl ketones. It is converted into RCOCH2OH plus N2. This is hydroxymethyl ketones. Hydroxymethyl ketones. And for more importance for this diazoketone, the intermediate diazoketone can be isolated and further converted into ester and amine. We have a intermediate compound diazoketone. So when we treated with this diazoketone is treated with ammonia NH3 and used as a Ag2O as catalyst. So it is converted into RCH2CONH2 and this compound is amide, and this compound is amide. And if this diazoketone is isolated, so we also one more reaction for this diazoketone. Alcohol is treated in presence of Ag2O as catalyst. then it is converted into ester, RCH2COOR dash, and this is R dash, alcohol. So this is ester. This compound, this is acid. This is hydroxymethyl ketone. Hydroxymethyl ketone. So the intermediate step diazoketone is very important. This is fourth application or example of diazomethane. Now we see more example, one or two more example for diazomethane. Diazomethane used for ring expansion. Ring expansion. Diazomethane is used for ring expansion. Certain cyclic ketones, when treated with diazomethane, undergo ring expansion to form higher ketones. Higher ketones, as for example, cyclopentanone to cyclohexanone. Cyclopentanone, we have a structure of cyclopentanone, CH2, 5 carbon ketonic compound, CH2, this is cyclopentanone. Cyclopentanone, and this cyclopentanone is treated with diazomethane, CH2N2, then it is converted into cyclohexane. Ketonic compound, but one carbon atom is more, so it is cyclo 1 2 3 4 5 6 hexanone, cyclohexanone. So cyclic ketones, when treated with diazomethane, undergo ring expansion to form higher ketones. The reaction has been used to prepare 6 to 10 member cyclic ketones. This reaction is used to prepare 6 to 10 member. Here we see 6 member, also 6 to 7, 7 to 8, 8 to 9 and 9 to 10. So this reaction being used to prepare 6 to 10 member cyclic compounds. And last application we see number 6, synthesis of heterocyclic compound. Synthesis, I about board, and then we show this application. Synthesis of heterocyclic compound. With the help of diazomethane, we synthesize some heterocyclic compound. With the help of diazomethane. Pyrazolene and pyrazole derivative are prepared by the condensation of ethylenic and acetylenic compound with diazomethane. Ethylenic CH2 double bond CH2. It is ethylenic. Treated with diazomethane. So it is converted into heterocyclic compound. This is pyrazolene and acetylenic compound. And this is pyrazole. So, with the help of diazomethane, we synthesize heterocyclic compounds. Here we complete our reagent diazomethane. Thank you.